Chapter 20, Electrochemistry. This is what I studied in grad school. "One day, sir, you may tax it," quote from Michael Faraday, in response to Mr. Gladstone, the British Chancellor of the Exchequer, when asked about the practical worth of electricity, right? So, he's working on this stuff, and they're like, what good is this? Well, it actually was incredibly good, huh? And that just kind of demonstrates the value of science for just pure science sake, because you never know what you're going to find. Okay, so we're talking about electrochemistry. We're going to be talking about electrons and electrical current. So lightning, which we don't usually see very much here in the Central Valley, but we've seen it a lot in the last couple of weeks. That is a dramatic demonstration of the power of the flow of electrical charge. If you've ever seen something that's been hit by lightning, a big tree is just like split down the middle. Sometimes it catches fire. There's this huge crack of noise. So that is the flow of electrons away from a negative charge towards a positive charge. And if you're interested, you can look it up about exactly how that happens and how the charge separation builds up during a storm. It's kind of interesting. Batteries work on similar principles, that we have a separation of charge, and so the electrons will naturally flow towards the positive charge. So same driving force for lightning and batteries. Oh, see, got ahead of myself. Always. The explanation's right here. So in the thundercloud, you get these violent air currents that cause the water droplets to collide with ice particles. And it's so violent that electrons get knocked off of the water molecules, and that creates some positive ions and some negative charges. So the positive charges accumulate on the ice crystals, which are going to move towards the top of the cloud. Rising air currents are going to bring those up. The negative charges remain in the wet, slushy bottom part of the cloud. And that charge separation will exist until a channel of ionized air develops. And that ionized air allows the current to pass, and you get this massive amounts of charge flowing through the ionized air, and that's what lightning is. So most lightning, and especially the dry lightning that we see, happens within one thundercloud or between two different thunderclouds. It's just up in the sky, right? It doesn't always hit the ground, but sometimes it does. If the clouds are close enough, then that negative charge on the bottom of the cloud causes the ground to develop a positive charge. You can get that ionized air forming, and bang, you've got cloud-to-ground lightning. Very dangerous. Any questions? So a few words about batteries. We all know what batteries are, but do we know how they work or why? So a battery is composed of two substances that have different affinities for electrons. One substance wants those electrons more than the other substance does. And when you separate those substances, one will develop a positive charge and the other will develop a negative charge. That charge separation exists until we get a path that can conduct the electrons from the negative end to the positive end of the battery. And a lot of times, what's forming that conductive path is a wire. It'll be interrupted with a switch. It might be going through your cell phone or going through a light bulb to give power to it. So the metal wire connects those charges, and they flow always from negative to positive. Why do the electrons flow towards the positive end? Because they're negative, right? And opposites attract. Opposites attract. Yeah. So they're with these negative charges. They are repelled by the other negative charges, and they're attracted to the positive, and so that's where they go.